Good morning students. Today we are going to explain about 2D frame analysis and design by Staad Pro. So here you can see this one is a 2D frame. Actually that we are also called as it as portal frame. So you can see that two columns and beam is resting on the two columns here. Discontinued the frame with the 2D dimensional. First we'll go for the new project. Choose the plane. File name is 2D frame. Length units are meter, force units are kilonewton. Setting on the default condition. Go for the next. Add beam or open structure visual. So we can draw or we can use the open structure visual now. So here you can see the frame models. The model type it will show here, prototype model. This one you have to go for the frame model and choose the bay frame and drag it into the middle of the screen here and we'll get these measurements. Like width is 0 because it is 2-dimensional. So once we click OK, you can see the number of ways and along length and height wise. Go for the transform model S, click OK. So this is the first step, actually geometry. The dimensions we can display here. So once first step is finished geometry, you can go for the second step. The geometry, what are the commands we are using means run structure visual. It will be helpful for creating any prototype models there. In that one we choose the bay frame in the frame models. So this is up to step 1 geometry. And further we can go for the second step. That is general, and the general and the classifications will be there, the 3 kind of things: property, supports and loadings. Geometry below bottom of that icon you can see the general, and that one first one is property. We'll go for the define, giving rectangle 0.35 and 0.45. It's representing depth and width of the beam. Giving assign to view. The same property we are giving to columns and beams equally. We can give separately also. So you can check the 3D rendering. Right click on that one. You can see the 3D rendering view. So this one is called as the 2D frame or portal frame. So property is finished. Second step is in general. We went for the property. That one define. That one rectangle we taken concrete material. We gain the dimensions YD and ZD. So second step is over. The third one we'll go for the supports. Now below the property specifications we'll ignore. We'll go for the support. Creating a fixed support now. Create. You can see the fixed support. Taking the support 2. So we can use a use cursor to assign the bottom of the columns that we can assign the fixed support. So this is your step 3. General, support, create, fixed support, and we are adding. So step 3 is finished up to now that we have created the supports for the bottom columns. We'll go for the next one, loads and definition. That one load case details, add. So the cases will be two cases: dead load, loading type 1, case 1, add, and we'll choose a second type, live load, add, and we'll close this one option. So step 1, dead load, add. The self weight will be common to all the experiments. Every structure will bear its own self weight. Y direction factor will be -1. We are giving assign to view. Next one, live load, add, member load, uniform force, nothing but UDL we are giving, uniformly distributed load, giving the -5, GY direction, add global Y direction, close it, and we are choosing uniform force -CY. Only beams parallel to x-axis we have to give that condition. So normally when we are giving the load specification in the third one, general loadings, so as you can see the structure in the picture here, so dead load it will be common to all the experiments. When you're taking for the live load, it won't be that much, because maximum in this kind of structure we won't get the load that much on the above the beams there. So approximately we are giving somewhat -5 kilonewton like that. So dead load it will be common. Live load for the beams it will only be at the UDL, uniformly distributed load. That we are also called as the uniform force in this one, Staad Pro. So we are taking the load, uniform force, select, beams parallel to x-axis, assign to only selected beams. When we choose the option of select particularly, we have to give for only assign to selected beams. You can see the load distributing on the beams. Next one, fifth step, we're going for the analysis. So analysis and print also it will be in common in all the experiments. It will analyze the structure depending on the shear force, bending moment, deflection, all the condition. Analysis, no print, add, close it. We go for the next one, design. So it's a concrete structure actually. So last step, design, concrete. And for the codebook, IS 456, Indian Standard 456 for the reinforced concrete design of the structure. So in that one left column, as you can see, the pace controlling, concrete we have to choose. In that right side panel, we have to click IS 456. We are selecting the current code book there. We'll go for the defined parameters. So maximum will give the two parameters, FCK, FI main. So compressive strength of the concrete I given 20,000 here. FI main I'm giving 415,000. Add, close it. So these are called as the design parameters, and this one is called as a design commands. Design beam we are giving, design column will give, and takeoff for the estimation. Another two parameters commands will give that to the beams and columns there. Close it. So FCK for the total structure. So assign to view, assign S, FI main, assign to view, assign. So when you're taking for the beam, so I'm mentioning the parameters again in the PPT here. Design parameters, FC, compressive strength of the concrete, FI, yield strength of the steel only for the main reinforcement, and the commands are design beam, design column, and takeoff, because in the structure only two parameters existing there, two kind of the structural element. Those are nothing but beam and column. So that's why we are giving design beam and column. So design beam, when we select that one, select beams parallel to x-axis, because system don't know what is the beam and what is the column. So particularly we have to choose it here. So we are giving design beam assigned to particular selected beams. Now when you are taking for the column, select beams parallel to only y-axis we are giving. So assign to selected beams, assign. So as you can see there, all get into the tick mark of green color. So completed. Go for the analyze, run analysis now. So the programming is running now. So Staad Pro abbreviation, you already know that one. Structural Analysis and Design Program. So it's a program running. You got the 0 warnings. That means structure is safe under condition. You can see the output file now. So from the procedure, you can see that one, beam, concrete design. So here you can see that one FCK value, FI value for main and shear. And here you can see the length, size of the beam and clear cover 25 mm. This one is a summary of reinforcement required. At the bottom side you can see the provided also. So singly or doubly reinforcement, that we can see the clearly top and bottom reinforcement existing here. So we can mention this one is a doubly reinforced beam. So this one is a column reinforcement detail. Same FCK F5 and length of the column, clear cover 40 mm. You can see the diagram also now. Beam concrete reinforcement design. So one beam is resting on the 3 columns as you can see there. So bottom, these are the columns. Top one is beam. So this one is a column concrete design. You can see the rectangular column. Here you can see that one, main reinforcement and tie reinforcement. Design parameters completely mentioned in the side box. So this is how we will analyze the structure 2D frame. You can see the FX, axial force, shear force in another direction, torsion. So you can see the bending moment diagrams also. So apparently structure is very safe, so that's why it is not getting any deflection here. So this is completely 2D frame, how we are going to analyze the 6 steps: geometry, general, supports, property, loadings, analysis and concrete. So you remember that why we are designing means 2D frame is also called as a portal frame and also called as a somewhat bay frame also. So maximum this kind of structure will use for the temporary constructions which can bear the load immediately, and not permanently, that will go for the temporary kind of structures. On that one we can design the 2D frame structures.